The key to sampling is having the right sample size, and in order to get the right sample size, we have to have the right sample calculator. You can use the roadmap presented here as a guide in selecting the right sample calculator, because there are many, many, many sample calculators, just a few of which we present here. So we'll start up in the left-hand corner here, and then the first question that we're asked is, do we have lot acceptance? In other words, are we intending to use the sampling to accept lots or reject lots? And the idea is that a lot comes in, we pick a number of those items, and based on whether X number pass or fail, then we reject or we accept the lot. So if that is your intent for sampling, then the next question is it attribute or variable data? In other words, is it attributes you're checking, or is it variables, variable type data that you're checking, or characteristics that you're checking? If it's attribute, then you're going to use a now decommissioned US military standard 105E. It's still available out on the internet. You can go and look at it there. If you'd like sort of an updated copy, it comes from ASQ, and it's ASQ Z1.4. If you're measuring variables, then you'll want to use US military standard 414 or ASQ Z1.9. I don't cover these in this module, perhaps at another time, but they're readily available. It's all pretty much table driven and quite easy to follow. If it's not lot acceptance, then is it in process sampling that you want to do? So you've got a process and you want to just monitor the condition of the process, then you would use SPC or pre-control type sampling. If neither of those apply, then the next question we ask is it confidence interval sampling or hypothesis sampling? Confidence interval sampling ignores the beta risk. You would use this when you want to get some indication as to what the population looks like. Confidence interval sampling is what is used in exit polling and other voting type polls. That's confidence interval sampling that you would typically use. And similarly, is it attribute or variable data that we're dealing with? And if it is, then we've got two different calculators to cater for either of those. If it's not confidence interval sampling, if it's hypothesis sampling does include the beta risk. It generally answers the question, to what extent does something exist? Whereas confidence interval sampling is, give me an idea what the population looks like. Hypothesis sampling is, tell me whether or not a certain condition exists. And then the next question is it attribute or variable data? And if it is variable data, then we have to determine whether we're dealing with one, two, or more samples, and depending on the answer to that, we'll use one sample or two or multi-sample calculators. If it is attribute data, then the question becomes, do we have one proportion? This would be like proportion of defects. Is it 1 or is it 2? And likewise, we would use the appropriate calculator. So along the bottom of the spreadsheet, the sample calculators .xls, there's a tab for each of these calculators, and we'll have a look at one of those now. We'll look at the hypothesis sampling one proportion. The first question or the first parameter that we want to put in the calculator, is it a one or two tailed test? Now that depends on what your hypothesis statement says. If it's less than or greater than, then it's one-tailed. If it's not equal to, then it's two-tailed. So suppose I have a one-tailed test. My alpha is the complement to my confidence level. And in this case, I've got 95% confidence level or a 5% alpha risk. Beta risk is complement to the power. So with a beta of 0.01, I've got a power of 99%. This is my ability to detect an issue if it exists. P naught is the proportion of my population. Now many times you won't know the proportion of defects in the population, and what we do in those cases is put 0.5 or 50%, and what you'll notice as you play with this and use it, what you're going to find is that a P naught of 0.5 gives you the largest sample size of any other sort of combinations, as it were. So when in doubt, use 50% defect rate. I know that's very high, but again, it gives you the largest sample size. And then the proportion of defects in the sample itself, and we may not know that either, but what we do want is the difference between these two numbers, which is the detectable difference. So what proportion of defects do we want to detect? And then we'll get our sample size. Now, I always get the question, what about the population? And in some online calculators and even some commercial products, they'll ask you for a population. You do not need to use the population. If you do not, you're actually on safer ground because your sample size will be slightly larger than the alpha and the beta require, particularly if you've got smaller sample sizes. But it is safe ground, and so I generally ignore the population unless my sample size is getting very close to the limit of what the number of items in my population. So that's it for sample calculators.